It's very nice to see you here all this evening. This is, we had some lectures last week, and this marks a new tack, as it were, for this semester, and that this is the beginning of a micro series, a small series, on which we've called NYU Abu Dhabi. Excuse me, not NYU. That's a déformation professionnelle. I mean, New York Abu Dhabi Futures, which is a series that we hold in order to try and bridge the programs that we hold here in Abu Dhabi, as well as at 19 Washington Square North in New York. It allows us to connect the programs that we foster and manage here in Abu Dhabi and New York. Last year, we held in this series a number of lectures on the subjects of sea level rising, on green buildings, on mega projects and transportation. And this year, we plan, as well as to continue tonight's lecture, to hold some discussions on economic development. And also issues of housing, in particular the problems of the crunch in middle class housing, which is an issue that affects actually Abu Dhabi as well as New York. But let me cut to the point. We're here to listen to Professor John Hansman on the subject of airports and the way they affect economic development. And that's obviously an issue that is of particular importance to Abu Dhabi. I visited the Emirates in 1982, and it was a tiny place compared to what it is now. It was a charming place, and I loved it then, and that's why I ended up coming back, but it was quite different. The importance of aviation, of the Emirates in global aviation, of course, escapes no one. And it can strike one in very superficial ways. Obviously, there's a complex and proper way of understanding this, which I'll leave to our speaker today. Just from a purely superficial perspective, as a follower of Premier League football, I'm struck that anybody who supports a team or watches a football game in the UK is likely to be watching a team that is sponsored by one airline, and against another team that's sponsored by... No, one team will be sponsored by Etihad. The other is likely to be sponsored by Emirates Airways, whether it be the team that you support or the team that you have an axe to grind with. Professor Hansman has an extraordinary CV. He's a professor of Aeronautics and Astronautics at MIT in the Department of Aeronautics and Astronautics, and he is the head of the Humans and Automation Division. Also at MIT, he's the director of the International Center for Air Transportation. He has an extraordinary array of patents. He holds no less than 6 US patents in various fields to do with technology and the engineering in aviation, and he has authored over 250 technical publications. He conducts research in several areas related to air transportation, flight vehicle operations, and safety. And his current research focuses on information technology applied to air transportation systems, air traffic control, integrated human automation systems, advanced vehicles, and advanced cockpit information systems. And he's a great person in conversation to talk about the applications of those areas of research, and I do encourage you afterwards at our reception to stop by and speak with him. He is a fellow of the American Institute of Aeronautics and Astronautics, the AIAA, and gave the 2005 National AIAA Dryden Lecture on Research. He consults and serves as a member of numerous advisory and technical committees, including the FAA Research and Development Advisory Committee and the NASA Aeronautical Research Advisory Committee. He has over 5,000 hours of pilot in-command time in airplanes, helicopters, and sailplanes, including meteorological, production, and engineering flight test experience, which is an extraordinary amount. and I wonder how that translates into air miles. He also, as well as teaching and researching at MIT, he got his PhD from there in 1982 in physics, meteorology, aeronautics, and astronautics, and electrical engineering. And he has numerous awards, which really are too numerous to enumerate here, but they cover the fields of teaching, research, and links with industry. It's a great privilege to welcome John Hansman to the podium.
It's great to be here. I flew in, although there was a snowstorm on the way. There's no snowstorm here. I was given this, when I was asked to do this, I sort of took it as an assignment to do sort of a comparative analysis between Abu Dhabi and New York in terms of the air transportation systems and where we are. I thought I'd first start, and I like to start talks like this, with a movie. This is actually a movie of the US system showing sort of 24 hours of traffic. It starts in the afternoon period. You can see there's a fair amount of traffic. As we go into the overnight period, you can see the traffic dies down. You can see transcontinental traffic going across the US, and you can see some flow into and out of the cargo hubs in the middle of the country. As dawn hits the East Coast, you can actually see the traffic blossom as it grows across. In peak period, midday traffic is about 5,000 airplanes being tracked by the US system in terms of air traffic control. But the thing to really look at is the sort of dynamics of the system. So you really have this complex net. It extends not just in the US, but across the world. So you have this traffic dynamic happening around the world. I'll show you another video of this at the end of the briefing of the entire world. Now, if you go to that figure that I had up in front of you for the past 15 minutes, that was actually shows you the density of traffic around the world. So you can see we have a high density of traffic in North America. In Europe, you have a fair amount of traffic, in this region, and then you have traffic on the Pacific Rim. If you actually look at this map and you compare it to the population density of the world, in general, air transportation sort of correlates with population density. But if you look more carefully and look at the trends in air transportation, these are trends in passenger transportation in a measure that we use. This is revenue passenger kilometers by world region as a function of time. You can see the top, the sort of black in this presentation plot is North America. You can see that there's been a fairly significant growth in air transportation in the US, really starting in the late 1970s after deregulation of the US airline industry. There are peaks and valleys. You can see there was a drop-off after the attacks of September 11th. You can also see that there's been a drop with the recent world economic pullback. The blue curve is Europe, and you can see that it generally tracks in a similar way. In the magenta curve is Asia Pacific, which have been the sort of three dominant regions, where the Asia Pacific growing fairly rapidly. If you look at the other world regions in the lower part of the plot, the thing to note here is the rapid growth of passenger air transportation out of the Middle East, really starting in 2000 and sort of growing very rapidly. If you look at the freight traffic, this is freight ton kilometers by world region. It has a similar characteristic. There's a couple of interesting differences. One of the things you'll notice is that really in the early 80s, or correction, early 90s, Asia Pacific became the leading source of air freight around the world. And that there's been more volatility in air freight in the past year or two due to the economic downturn. The other thing you'll notice is, in fact, the growth in air freight out of the Middle East is in some sense stronger than the passenger growth. And the Middle East traffic didn't drop down as fast as the rest of the world in the recent pullback. Now, the way we look at this, from a sort of overall large systems standpoint, is through this little model. This really looks at the relationship between economic development and air transportation. I have background in control theory, so we sort of tend to look at these as sort of control feedback plots. So what you have here is the airlines and air cargo producers who provide supply of air transportation into the system. The demand is provided by the economy, and there's a pricing and a revenue feedback loop going on in the inside here. But we also look at the external effects, And one of the things we're very interested in is the impact between air transportation and economic development. Now, in traditional sort of economic analysis, what you would do is you would look at the direct, indirect, and induced employment effects. Basically, people who are working for the airlines and the money they spend in the economy, et cetera. One of the things that we believe is very important, but is actually very hard to measure directly, is what we call the economic enabling effect. In Europe, this is called a catalytic effect of air transportation, which is how does air transportation provide access to people, markets, ideas, and capital that allow growth of the economy. And this is particularly important in an economy that's growing rapidly. It has a somewhat different dynamic when the economy is mature. In the hypothesis is that there's a very sort of strong correlation here. Now, there's a lot of data to support the correlation. There's not necessarily data to support causality, right? So we don't know whether air transportation grows because there's a lot of economic development or air transportation stimulates it, but we hypothesize that there's a stimulus effect. Now, you can see this. This is the correlation. Here's correlation between, for U.S. data, this is correlation between the U.S. gross domestic product and passenger traffic. The black is the system revenue passenger miles year by year. The red is the GDP. And you can see there's a clear correlation in the behavior. You can also see during periods of recession, which are shown here in gray, there's a pullback in both the economy and air transportation activity. Now, we can look at this hypothesis another way. This is actually looking at it in terms of world region. In this plot, what I have here is the gross domestic product per capita of different countries versus that same measure, passenger kilometers, revenue passenger kilometers per capita. Note, by the way, on the left-hand side, this is a logarithmic plot, so this is a very significant effect. What you see here is there's a clear pattern, there's a clear correlation with the growth in air transportation activity with GDP. You can see the US, which has the highest GDP per capita, is among the top countries in terms of activity. The other thing that you'll note here, by the way, is that the size of each of these bubbles is actually the size of the population. So you can see why, from an air transportation standpoint, people are very interested in India and China because the expectation is that the GDP per capita will rise in these regions. So if you take these guys and assume they'll slide up the curve somewhat, and these large size of their populations, you expect a significant growth in air transportation in those regions. Now, the other thing I would point out is that you have some countries that sort of slip off these curves. And generally, in the ones that are plotted here, like Singapore, New Zealand, Ireland, you have countries that tend to be island nations, so are somewhat more dependent on air transportation, okay, and are generally above the curve. So again, that's consistent with this hypothesis of the relation. Now, I apologize, before this plot was made before I was going to give this talk, so I actually went back and had a student, or I had another student who had done a thesis who actually kept the UAE bullet in here. So you'll actually see that this is slightly different measure, but it's the same type of curve. And you see the UAE here is actually the furthest off the curve in terms of its interaction, sort of super growth of air transportation. Now, you can also look at this. This is a plot of relative growth rates. This is looking at the growth of air transportation between 1985 and 2005, again by different countries in world regions. The vertical axis is GDP growth, and the horizontal axis is air transportation passenger growth. And what you see here, the blue is the U.S. Okay, so they were neutral in GDP growth and actually a little slower in air transportation growth, where the UAE is right at the top in terms of air transportation growth. Vietnam is here, but it's an outlier because essentially there was no air transportation in Vietnam at the beginning of the period. So it's really at the top of the air transportation growth and among the very significant in GDP growth. So if you actually plot this, and this is UAE GDP and passenger trends. So what we have here is the red is the GDP in constant US dollars, and the blue is the UAE scheduled airlines, okay? So we, everything is pointed towards this significant growth here. So one of the things we look at from a systems engineering standpoint is sort of system evolution. So if you go to a classic S-curve model of a system evolution, the hypothesis is that, that the UAE and Abu Dhabi is here right at this sort of takeoff point. So we're at a period of significant growth in air transportation in Abu Dhabi, which we expect to continue significantly. The question is, where is New York on this plot? Okay, and let me tell you, New York is not here. Okay, and we'll come back and talk a lot. But it's very interesting to see the contrast and the reasons for the contrast. Now, from an infrastructure standpoint, and I sort of, by the way, as part of this lecture, you give it both in New York and in Abu Dhabi. Okay, so I have to explain to some of the New York people some of the topology of Abu Dhabi. So I apologize for this, but as you know, we're here in Abu Dhabi, which has got 2 airports we'll talk about. There's 2 significant airports in Dubai and in Qatar. So we really have a significant sort of hub of air transportation activity here. The Abu Dhabi airports, there's the Al Bateen airport, which I understand was the original airport, was too small. By the way, this is a very standard pattern. The Abu Dhabi International Airport was built outside the city, which had significant potential for growth. In Dubai, there's the Dubai International, and then the Al Maktoum International Airport, which are there. And again, you can see there's significant potential for growth. If we look at activity and departures by airport, these are the Middle East airports. You can see, for example, Abu Dhabi Airport between 2008 and 2010 has had about a 20% growth. But almost all of the airports in this region have had significant growth. So this has really been, as I said, a period of significant growth. Now, I want to get into a little bit of why it's been going and sort of some of the opportunities. There's obviously a lot of things going on, but this is a world plot projection. And this is a typical way that airline designers look at markets and planning plots. So this is a market range plot centered out of Dubai. And what you have here is 3,200 nautical mile range, seeing all the places you can get there, an 8,200 nautical mile range. It turns out that for very long haul transport, Abu Dhabi is in the UAE is incredibly well positioned as sort of a hub between many of the major places in the world. So you can see at the end of this, and I'll come back in a minute, but 8,200 miles is the range of long-range transport aircraft. So once we got aircraft that could make this range, that sort of opened up the window that this was a reasonable place to think about siting a hub. Okay, so you have basically all of the U.S. cities you can hit at 8,200 nautical miles range. You can hit almost all of South America. You can easily hit all of Asia, and you can make it to Australia. And if you wanted to, you could go to the South Pole, but there's not much of a market. Okay. Now, the aircraft that really sort of enabled this, and you're familiar with all these airplanes, almost all of us probably came here or travel. I came here on one, but there's also, we do a lot of travel with these. 747-400 from Boeing, the Airbus A340, the A330, and 777. And you can see what I've put here is the ranges. So depending on the model, the ranges are between 7,200. 777 will go up to 9,300 nautical miles. Airbus A330 will go to 8,490, and the 340 will go to 8,700 nautical miles. So basically, you can make those range rings. If you look at the new airplanes that are coming down the pipe, again, they're all designed to make this range capability. So you've got the 747-800, the Airbus A380, which we all know is already in operation. The 2 new airplanes that are coming through, the Boeing 787 and the A350. So essentially, all long-haul airplanes are really being designed for this market. Now, if you look at this plot we just saw, okay, of where Abu Dhabi falls in the map, and then think about New York. New York has got a very different characteristic. It's not well positioned as as a hub, okay. And in fact, New York really does not operate as a hub. New York operates generally, like Kennedy and Newark, operate as a port of entry into the U.S., which is this very significant market. So there's a very different dynamic of what's going on. Although it's a very important airport, or the New York airports are very important, they sort of have a different characteristic. Now, if we look at if you remember that traffic I showed you out of the UAE, if I look at the traffic at New York, okay, this is annual aircraft movements as a function of time, you actually see that New York is saturated, and we really have been capped at the number of aircraft movements we can have, more or less for the past 15 or 20 years. So that would actually tend to put you up more where I put New York in this sort of saturation point. So the hypothesis here is the New York system is sort of reaching its saturation threshold. And it's interesting to reflect on what that means in terms of its potential for economic development under this prior hypothesis. So let me give you some evidence of what's happening in the U.S. system. So this is actually flight delays in the U.S. system, plotted as a function of time. The green line is the 12-month trailing average, and the blue line is the month-to-month data. So one of the things you see, which is very interesting, is there's a general increase in delays in the U.S. system. They actually dropped off after September 11th and then built up again. But actually, more interesting is the volatility in the delays. So you'll actually see that the delays spike up very suddenly. And this actually happens in the summer months. So the delays peak due to thunderstorm and convective activity. And I'll explain to you in a minute or two why this happens. But it's an indication that the system is actually reaching its capacity constraints at key airports in the system. And those key airports actually are in the New York region. So these are the delays out of the key New York airports, Newark, LaGuardia, and Kennedy. And you'll see that, again, they spiked up before September 11th. They went down and have driven. In general, this is the most congested place within the U.S. system. Now, this is a movie of traffic going into New York. New York is right up here on the right. You'll notice that there is weather moving into New York. And I want you to look carefully. You'll notice all the airplanes that start to go into holding patterns, which are circles here. This is an indication that you have congestion that started back up. And you'll see that when the weather hits New York, you actually have airplanes in holding patterns all the way across the U.S. Okay, so that's an indication. Remember that movie I showed you a few minutes ago? Because of these dynamics, the delays propagate throughout the system. And of course, once airplanes start to get delayed, there's a knock-on effect because the airplanes then don't make their departure, so then they don't make their next flight and connect. So this is a real problem for the U.S. internal system. Now, if we think about what limits the capacity of the system, it can be limited at the airport level. Okay, it can be limited at the airspace level in terms of airspace design. It's a function of the demand on the system. In one of the characteristics of hub airports is we tend to have a spike in demand because you have all the aircraft coming in with the passengers who are going to then exchange for the outbounds. So we get this, that tends to spike up the demand, make the problem worse. And it's exacerbated in some cases due to environmental limits, which we'll talk about. So when we think about the airport, which in the U.S. tends to be the limiting factor, one of the things we do here, this is a little queuing model that we use. So you can imagine airplanes flow into the system through the entry fix to the regional area. They fly through arrival paths. They share the resources of runways, taxiway, ramp, and gates with the departures. At the gates, they turn and become departures. One interesting thing to think about on mature airports is an airport is an adaptive system. So what that means is that if we hypothesize, and I'll show you in a minute, that runways are the key constraint in the U.S. system, the rest of the airport, the taxiways, ramp, and gates, basically adapt to the capacity of the runways. So if you were to increase the capacity of the runways, you wouldn't have enough gates or ramp area. So you really have to think about this in an adaptive system. But the hardest thing to add, at least in the U.S., are runways. Now, the thing that limits the runway performance is what we call wake vortex separation. This is a picture of a wake behind an aircraft. It's just a very classic NASA picture. So you can see the wake off of each wingtip creates turbulence, which is in fact dangerous behind the aircraft. As a consequence, we have separation requirements which depend on the leading and trailing aircraft. So these are the radar separation requirements in the U.S. as a function of the size of the aircraft. So a small aircraft following a heavy in this example requires a 5-mile separation. Okay, a heavy aircraft following a large aircraft or small aircraft requires only 3 or 2.5 mile separation. So the capacity of a single runway will vary a little bit depending on the traffic mix, but the order of magnitude is about 60 flights or operations an hour that you can handle. Now, this airplane, A380, has actually thrown a little bit of a monkey wrench into the works here. Because it's the largest current airplane, there's a big debate about what the separation requirements should be. Right now, depending on where you are in the world, the separation is between 7 and 8 miles. Okay, which is not too bad. Anything more than that, and it actually really penalizes that airplane in terms of its seat performance. So the additional seats you get out of the airplane get offset by the separation requirement, unless you're flying lots of A380s, in which case it's not such a problem. So maybe it won't be an issue in Dubai. Now, the way we look at airport capacity traditionally is through these capacity envelopes. I just showed you the example of my home airport of Boston here. So on the vertical axis is the arrival rate per hour, and the horizontal axis is the departure rate per hour. And airports with bad geometry like this, Boston Logan has terrible geometry, really sort of has to trade off. They can't fire off departures and take arrivals at the same time. They have to make a trade-off. So that the Pareto frontier or performance envelopes are not symmetric. Now, the other thing you'll notice at an airport like Boston is this is the visual flight rules. This is the good weather condition. This is the instrument flight rules or bad weather, low visibility performance. So the capacity of the airport varies significantly as a function of the weather. These are the New York airports, LaGuardia, Newark, and JFK. These are the 2 international airports. Teterboro is a corporate aircraft base, but it's close in. And these airports are all very close to each other. They're all within about 15 miles. So it's very tight airspace. These are the capacity envelopes of the observed capacity envelopes of the New York airports. And I apologize, these are departures per 15 minutes, so you have to multiply by 4. Kennedy, one of the things that happens when you get delay is you get significant increase in taxi out time. So this actually shows you for U.S. airports that the JFK airport has the longest, has the highest percentage of taxi out fuel burn in the U.S. taxi out performance in the U.S. system. In part because of its congestion. This was exacerbated this summer when they actually had to close a runway for repaving. Now, as I indicated, the capacity of the airport varies with weather. One of the advantages that you have in this region is the weather is generally pretty good compared to the other sort of many of the other main airports around the world. So this is New York and Abu Dhabi in terms of weather comparison. You can see that we have 81 days of rain in New York, and you have, according to the data I saw, 14 days of rain in Abu Dhabi on average. Fog is actually a little bit worse here, but much better in terms of convective weather. And you really, like I say, don't have a snowstorm problem. Like I say, I almost missed my connection at Kennedy due to a snowstorm. Okay. So when we get this variable capacity effect, so this is old data, but it illustrates the point. This is the total number of operations in airports, and this is the number of delayed flights per 1,000. What you see in generally as you get more flights, as you would expect, you get more delayed flights. However, there's some airports that are way off the curve in the bottom that don't have many delayed flights. Now, if you look carefully, these are Honolulu and Las Vegas. Okay, so again, places like Abu Dhabi who have very good weather. If you look at airports that have significant delays, there are places that have weather problems. San Francisco's got a fog problem. You got LaGuardia, Newark, Boston, JFK. Los Angeles is actually almost on the curve. Now, I want to sort of show you how this propagates in the system and where we get the nonlinearities. So this is a little hypothetical exercise. So imagine I have an airport here, and this is the schedule for the airport. So it's a hub airport, and it tends to run these banks of flights. At the peak period, when the airplanes are coming in for the exchange, I've actually got 60 flights an hour scheduled to come into the airport, which is above the nominal capacity of 50 flights an hour. Now, this turns out not to be a big deal. And by the way, this is a very common thing that airlines do. They'll schedule this way because they know not all the airplanes will show up at the right time. And even if I take some delay in the first couple of hours, in the relaxed time, I can actually recover that delay. So the bottom plot is the delayed flights in the system. Okay, so you see I get a few delayed flights, they recover, and I get delayed flights again. Now imagine the weather gets worse and the capacity of the airport drops to 40 flights an hour. What happens here is, again, now I get my delayed flights, but I start to run into a problem because I don't have enough headroom to recover all the delayed flights on the slack period. So you see that the delays start to accumulate during the day, okay, and will propagate, okay. Now this is pretty bad. It gets worse if I actually drop down to 30 flights an hour. At 30 flights an hour, once the first airplane is delayed at the beginning of the day, every airplane for the rest of the day will be delayed because there's no capability to make up that full recovery, okay. So, by the way, the scale of the plot here has changed. So this is a classic queuing theory problem where if you look on basically a queuing system, if you look at the demand on the system and there's some capacity limit, if you look at the delay in the system, as you start to approach that capacity limits, the delay will go nonlinear as you increase demand. And in the US system, and in particular in the New York airports, we're really in this nonlinear region. We're not in the nonlinear region in the Middle East yet. Now, how do you solve this problem? Okay, the obvious solution is to solve it with concrete. Okay, to build more runways. So I showed you Boston, my home airport. This is a new runway that came into Boston about 4 years ago. So it's a short runway that only works for regional jets, but it provides a runway which is in this direction, which is common when we have strong winds. Now, I want you to guess on how long it took for us to get this runway built. What? You got a guess? Any takers? 20 years? Okay. 37 years is what it took for that. Okay, right. It took 37 years to build this before the first thing. And this actually just shows you some of the airport expansion projects around the US. You can see that the US system, it's extremely difficult to add runway infrastructure capacity. Okay. I'll come back to it at the end, but a lot of this has to do with problems on environmental review and litigation that can come out when you go into environmental review. Now, the way the US system has adapted to this is with the emergence of secondary airports, something which in the air transportation literature called the Southwest effect. In Boston, again, is an example here. So we have Boston Airport, which reaches its saturation threshold. What we now have are secondary airports at Providence, Rhode Island, and Manchester, New Hampshire, within about 50 miles that provide offloading capability. And what happened is, and the reason why it's called the Southwest effect is Southwest Airlines initially went into these airports. They created enough legitimate travel or service out of those airports that it kind of kicked them into the next level, so they became credible secondary airports or alternatives. And if you look around the U.S., there are many multi-airport systems that have emerged in the U.S., okay? Particularly on the East Coast, a few on the West Coast, and a few in the middle. We also have looked around the world, and there's a significant growth of multi-airport systems around the world, and of course, this region is one of those areas. Now, I want to, going back to my New York assignment, sort of talk about the New York multi-airport system. So here's the airports I mentioned before. Here's LaGuardia, Kennedy, Newark, and this is the Teterboro Airport. So they're all in this very close proximity in the middle here. And if you compare them, like I say, to the UAE, where the airports, you guys have you have definitely a bigger scale, but you also have your own multi-airport system here. Now, we have looked at this, and this probably gets more technical than you want to hear, but I'll just quickly go through the idea. You can look at the air transportation system as a network the same way that the internet is a network. So there's theories called scale-free network theory about how these networks should grow. And ostensibly, bigger nodes, like bigger servers, should grow faster than smaller servers. And if you plot this, if you sort of go to this theory, basically on this type of plot, which is, you can think of this as the number of connections at an airport, or number of different destinations or flights out of an airport. If you plot, that's called the degree. If you sort of weight the degrees and line them up, you should basically be linear on this curve. And what you see is in the US system, if you plot it that way, the top 29 airports fall off the linear curve. That's an indication that those airports are not exhibiting scale-free growth. They're constrained for one reason or another. Now, if you actually go and resort the data and take all of the airport, this was done for the airports independently. If you now take all the airports like the New York airports and group them into one mega airport, okay, and replot the data, essentially it falls right on that linear curve. So what that tells you is that the way the US system has adapted to its airport runway constraints is to go to these multi-airport systems. These are not as efficient as one big airport, but it's the way the system has adapted. There's sort of further evidence of this. If you go back and look at this, like I say, hypothetically, each node should grow proportional to its size. So this is the relative size of the airport or multi-airport system, and this is the relative annual growth rate. And what you see here is essentially all the multi-airport systems are at or above the linear growth line, with one exception, which is the New York airport system. And what that tells you is that the New York airport system has actually filled up not only at the individual airport level, but at the multi-airport level. And there's just there's really no spare capacity at New York, okay? Now that's at the airport level. There's also problems at the airspace level, okay? In terms of airspace design, controller workload, and what we call balkanization, which is the difficulty of different air traffic components to work together. This shows you just an example of the traffic going into and out of New York in one sort of configuration. So this is Kennedy here, LaGuardia, Teterboro, and Newark. And you can see that for safety reasons, all of these arrivals and departures have to be routed so that they're what we call procedurally separated. They don't interact. And this is it's hard to see here. This is a three-dimensional picture or puzzle. So all of these trajectories sort of flow into or over each other. Now, this would be hard enough if this is the only thing you had to do, but it turns out that you have different configurations depending on which way the wind is blowing and what the weather conditions are. So these are, again, examples of New York configurations when the weather's in low visibility. And this is when the landings are going to the south. This is when the landings have to go to the north. These are actually VFR configurations, which have good weather configurations, have a little bit more flexibility. And in this case, the New York system can decide whether they want to prioritize departures or arrivals. Okay, so I don't expect you to really look at those. You're just supposed to think that they're complicated. Okay. One of the things that we've done at a theoretical level is to try to figure out if you could. I should mention here, one of the problems we have is that we can't max out every airport at the same time. So, if they need to push departures off of Kennedy, they end up having to constrain LaGuardia in order to allow Kennedy to operate at maximum performance. So there's an interaction between the four airports. And one of the things we've been looking at are ways to decouple the airports and how much performance could you get out of the decoupling. And I won't go through the full analysis, but I would sort of say that you just take the envelopes for these different airports. You look at if each airport could operate at its maximum performance, how much capacity could you get at the entire system? And by the way, this is what these little gray dots are. And the black dots are what the multi-airport system or Metroplex does today. And what it tells you is that there's about a 20 to 30% pickup in performance you could get if you could decouple the airports. So One of the things, I started with this this S-curve hypothesis. One of the questions, and this is a sort of classic innovation theory, is to look for some sort of discontinuity that would allow you to jump off the curve. So are there things that you could do to improve the system? Okay, one thing that could be done in New York is theoretically you could go to a rail system that would offload a lot of the airport capacity. So if you had a high-speed rail system that really worked in the Northeast Corridor, much of the traffic that in the U.S. actually flows in this area, you could offload that airport resource and it could make sense. Now, the U.S. has actually got some stimulus funding. Nominally, $8 billion has been allocated to high-speed rail. The problem is that for political reasons, it's spread all the way around the U.S. So it's sort of subcritical in every area. So you really are not going to get an effective high-speed rail system. I just, by comparison, showed that Chinese high-speed rail investment, they're right now in the order of 730 billion through 212 for a geographical region which is about the same size. Okay, so you can see that there's a significant investment in rail going on in China. So we're not going to probably work our way out of the problem with rail. There's a common understanding, recognition that both the U.S. and European systems won't scale to meet the future demand. I've been focusing on New York in the UAE. I should note that almost all of the problems I'm talking about for New York also occur in most of the European hubs. Okay. So they have the same constraints, they have the same weather problems, and they have the same difficulty in sort of increasing their capacity. So there are major long-term initiatives to improve the capacity of the air traffic control system. In the US, this is called Next Generation Air Transportation System. In Europe, it's called SESAR, or Single European Sky. I'll just quickly mention a few of the technical elements. Because both which are shared between NextGen and SESAR, and will become the world standards. So there's a plan for data communication infrastructure, both on the ground and between the airplanes and the grounds. Right now, as you probably know, we don't have very good data communication between the air and the ground in most airplanes. Okay. And part of this is just, it's not a technical difficulty, it's just an international agreement difficulty. It's hard to get to the international standard that would work, and nobody wants to invest till you get there. There's improved navigation performance, I'll mention in a minute, and improved surveillance performance. Let me just talk about the surveillance. Today, most air traffic control uses a radar to figure out where airplanes are. The transition will be to what's called automatic dependent surveillance broadcast. And the idea here is each airplane knows its position through a GPS or some other navigation system. The airplanes essentially broadcast that information to other airplanes and to the ground around them. So you send out once a second, essentially an email message or SMS that says, here's my position, here's my velocity, here's my next waypoint. And that then can be received on the ground and used for air traffic control. It also can be received by other airplanes in the area to allow you to coordinate airplane movements. Okay, so this system has a number of advantages. Probably the most important is that it's a fast update rate. The data is updated once a second. A typical radar, even a high-performance one, only updates once every 4 seconds. And a long-range radar is only once every 12 seconds. So the controllers really can't have the airplanes very close to each other because they don't know exactly where they are. Well, let me just, before I leave this, this has a huge advantage in regions where you don't have good radar coverage today. So the first place it's really become the standard is in Australia. Australia only has radar coverage on the coasts. And the outback is basically like being over the ocean. The beauty of this system is the ground components are very cheap. They're just basically radio receivers. So they were able to put radio receivers across all of Australia and essentially fill up this hole that they have in the outback. The Canadians have done the same thing in the northern part of Canada in the Hudson Bay, and we're seeing essentially this become the standard around the world. The US is committed to it, Europeans have committed to it, and it has significant advantages, like I say, for regions that don't have good radar coverage today. The other thing that's happening is using the advanced navigation capability we have on the airplanes. So most airplanes actually have very good navigation capability. There is a system called RNAV, which is area navigation, that allows the airplanes to fly point to point. And essentially 100% of the fleet has this today. There's a slightly more advanced version of this called Required Navigation Performance. Again, allows you to go to these waypoints that you can create. I should mention, in the old days, you used to only be able to fly to a radio station. Okay, so I can basically make a radio station and have a sort of optimal path anywhere I want to fly. The beauty of the RMP is two things. One, you can fly curved paths, which can be very useful. And it's a system that allows for varying degrees of precision. So as I get to good navigation capability, I can then require airplanes have that good navigation capability to fly very tight routes. And this can be an advantage if we go back to our New York example, where I can now allow airplanes to fly very precise paths and possibly decouple some of these airports. Now, I'll just give you an example. This is an example of the RNAV procedures in use. So these were departures, I don't know how well you can see it, out of Atlanta Airport. And you'll notice that this is before RNAV. So there are these red points were 4 departure gates. And the air traffic controller's job was to actually give airplanes headings to fly over these gates. And you can see that there's a significant dispersion in where the aircraft went. Okay. When Atlanta went to RNP procedures, so instead of having the controllers give headings, they actually had the aircraft fly the tracks. You can see that the dispersion went down significantly, okay? And in fact, they were able to move from 4 departure gates to 6 departure gates, which was a significant increase in the throughput capacity of the airport. Okay, so this is great, okay, unless you happen to live under this point, right? Okay, so it's actually it created an interesting problem. So as we start to improve the capacity of the system, we may be penalizing some people from a noise standpoint, and creates a very interesting political dynamic. I'll come back to that in a minute. So these are just some examples of what you could do. This is Newark over here in the yellow. So these are landings into Newark. The red, the white, are landings into LaGuardia. In this particular case, this is actually never done. What we did is we took 2 different days and overlaid them, because you can see that you have a traffic jam here, right? One of the things we can do is with the RMP procedures, we can shorten up the turn to final into LaGuardia. And the color doesn't work very well here. But again, you can run actually 2 arrivals into Newark, and we can bring traffic inside of the Newark traffic into LaGuardia. So it's just an example of what people are looking at in terms of these procedures. Now, I want to sort of finish on this sort of barriers to this. And again, this is something you don't have at the same level here that we have in the US. This decoupling of the New York airports is something that's been known for a while. The FAA actually went through a whole plan and did a redesign of the procedures into New York. Okay, but remember I told you that we haven't built any airports in the last 20, 30 years? A lot of this, if you plot it, after the U.S. Environmental NEPA, Environmental Protection Act in 1970, we've essentially had very limited capacity to build airports, because what happens is, this is a little feedback model of the system. So what you have here is the system, the airspace system. You have the behavior. You actually have change. This is looking at change processes here. So you have awareness building process of the need for change. You have some decision-making process, and then you actually have implementation. One of the problems we run into is in the safety environmental approval process, whereas if you have a stakeholder that doesn't like the idea, they can block the change through, in terms of environmental, it's through litigation, and safety approval, it's a slightly different process. We look at this, and this is a little model that we use on this. Often when people think about a project, they think about the sort of aggregate cost benefit. We sort of try to decouple the cost and benefits. So if you look in the simple example, So there are different stakeholders, stakeholder 1, 2, and through N here. Stakeholder 1 really likes the idea because they get a lot of benefit and they're not paying much cost, okay? Stakeholder N really doesn't get any benefit and is paying a lot of cost, okay? So if we go back to the overflight case here, if you start moving these trajectories over people's houses that they don't like, they can create a problem. In the U.S. system has actually been blocked by people who live up in this area. Okay, so this is a very wealthy part of the New York area. When they started to make the changes, there was a lot of resistance that was been in litigation. And it's been in litigation for 5 or 6 years. So this is a major challenge to us in the U.S. and the New York system. Like I say, I'm sure there are similar challenges here, but they're probably not at the same level for now. Okay, so in the event that we run into this system where we're into congestion and we can't make these increases in capacity, the only thing that really can be done in the short term is to go into what we call demand management, which is to restrict the flights into slots or some other sort of mechanism, which we hypothesize then will have an adverse impact in the economic development of the New York region. So there is this concern that New York will sort of stagnate in some sense, if their air transportation infrastructure stagnates. Now, of course, I'm an air transportation guy. I'm looking through it through one lens. I'm sure there are different ways to look at it. So, all right, I'll just finish. I promise I'd show you the world. So this is traffic on the world. If you look at the U.S., it actually has the same dynamic. You can see here, this is triggered. It starts during the day. You have the overnight flights going out of U.S. to Europe. You have the day waking up in Europe. You can see the traffic. By the way, this is a few years old, the source data, so we're not quite accurate in this region, and there's a problem in the Pacific. But you get some idea of the dynamics of the traffic around the world and how they work. So I think I'll stop here. I'll just let it play for a second and then stop it, and I'd be happy to take any questions.
I was wondering, is there any way to sort of increase the efficiency of getting passengers to their destinations? That is to say, reducing sort of connecting flights, or is that already at a point of saturation?
Yeah. So from a network perspective, or from a setting that, yeah. So we've actually done some interesting analysis on this. The hub and spoke network is actually a very efficient network from an airline standpoint. So let me just give you the example. If I'm an airline and I want to cover a network of 50 airports, let's say, okay? So I can connect that network. If I have one hub, okay, I can do that in the math is, you have n is the number of airplanes, 2 times n minus 1 flight. So they have to fly from the outer flights to the hub, turn around and go back. So I can cover that with 98 flights, okay? If I want to do it in direct service, if I wanted to connect every one of those airports, okay, it would be n times n minus 1 flights. So that would be 2,450 flights to cover the same network. So if you're an airline, you naturally want to do a hub. And by the way, if you're an airline, you have other things you have to do, like you have to do maintenance on the airplanes and you have to have crews. So airlines will always operate hub networks. We did an interesting analysis of the U.S. system where we have good data, looking at the fuel efficiency of the network. Okay, because the same thing from a passenger you can think of as fuel. So if you're flying extra distance, it's inefficient. What we actually found is that compared to the theoretical optimal, the topology of the U.S. network was efficient to within about 1% of what you could get. Okay, so you don't get a lot of advantage, at an aggregate level. Now, if you're the one guy who has to fly, extra, 5,000 miles out of their way to make the destination, you're not feeling it. But at an aggregate level, it's actually reasonably efficient, and it's a mix between hub service and then point-to-point service when you have sufficient demand to create the service. The other thing that we found, by the way, is that if you're worried about fuel efficiency, the thing that made a much bigger impact was to be able to size the airplanes exactly for the demand of the traffic. So if you have a market and your airplanes are either too big or too small, if your airplanes are too small, you have to fly multiple flights. Okay. If the airplanes are too big, okay, then they're not running full, which is inefficient from a fuel standpoint. Now, there's a whole other dynamic that goes on in the airline business, which is when you have competition. We've actually seen, and I could show you this data, that the average size of airplanes per departure has actually gone down over the past 20 years. And the reason is, in general, when you have competitive markets, you want to add frequency of service to compete. So you actually would rather have more flights on the smaller airplane than one large flight. That's part of what's congesting the U.S. system, because the U.S. system is really trying to provide services on the short range. When you have the long-haul markets that we have typically when we hub out of places like here, there's really only a few times a day that makes sense to fly. So it's not as competitive on the frequency of service, and you tend to compete on other attributes like service on the flight and price and things like that.
So Boeing feels the future is point-to-point. Airbus feels it's hub and spoke still. Based on your analysis, who do you think's winning or would win?
I think it's a draw. Okay, no, because it depends on the market. So actually, the hub and spoke really makes sense for places like this on the long haul market. Okay, on the other hand, when you're servicing dense markets, so there's a lot of point-to-point from the center of the U.S. to the center of Europe or things. So I think it's a mixture. Okay, and as we go sort of future in time, the question is, will the markets, where will you reach saturation, and where will you really get the bang for the larger airplane? The problem with the large airplanes is if you don't fill them up, they're inefficient. Okay, so you have to have markets that are strong enough that you can fill.
Here in Abu Dhabi International, we have a very close adjacency to Maktoum International Airport, the new airport in Dubai, and of course, Dubai International Airport. Yeah. And of course, then you have Sharjah and Ajman, and so we have, quite a density of airport. Yeah. I'm trying to visualize into the future, and could you not decouple this from now so that you don't face the same problems that you have?
So that's an excellent point, which is you, at least for the near term, are not as constrained by the airports. You have a capability to grow the airports, okay? But you've got such a massive growth here that you're likely to get a congestion problem, okay? Now, the advantage you have is you're following the U.S., okay? So our airports are 10 miles apart, okay? The good news for you is yours are 20 to 30 miles apart, so you sort of have more room. However, there are not many controllers around the world that are willing to operate as tightly as the New York air traffic controllers are. So I think there really will be a need in the future to do that. And I think there is an opportunity to really think about it. And I don't know the details of the traffic interaction plans here, to figure out how you would handle this with, times 4, times 10 traffic, with the existing airports you have. And it's too late now because most of the airport arrival directions are set, and they tend to be set by wind rather than other things. But there are some things you could do to adjust that. And I do think that you're going to be in better shape because these things like required navigation performance will become the standard in the future, and we'll have much tighter procedures. So I think it's something to think about, but it's probably not as critical a constraint as the U.S.
Just wanted to get your thoughts on, I know that in the New York metropolitan area, they've been working on trying to reduce the density or the capacity of flights in the 3 major metropolitan airports and spreading them out to regional airports, to Newburgh and White Plains and Stewart. Yeah. And
you want to take one?
Well, no, I've actually, taken flights explicitly not to go out there, Yeah. But what about combining the light rail or the rail and the idea of dispersing the traffic to those major airports? It's sort of like investing in the rail, so you have these direct trains to take you there. I think of Hong Kong, for instance.
Yeah, no. So the problem with multi-airport systems is you don't have the interconnectivity between the airports, right? So if you fly into one, it's hard. You got to get to the other, and you could do a better job there. However, if I was doing the investment, I would try to invest in the high-speed rail between New York, Boston, and Washington, because there's probably about 30% of the traffic or more that goes into those airports that doesn't need to be there. And if you were to offload those flights, if you were to make that really efficient, okay, then you would actually pick up more capacity than you would, as much as capacity as you buy by going out to Newburgh.
It's true.
Do you think some new global air transportation center gonna emerge soon in developing countries? Let's say Turkey and Istanbul, because it seems like a profitable business. Is there a possibility that next sponsor of Arsenal FC won't be Fly Emirates, but let's say Turkish Airlines?
I'd have to see. I mean, there is some indication that Turkish is doing well and whatever, and that they may provide a node for political reasons into other parts. Turkey is not bad topologically if you go look at the location. I think the difficulty would be is that they're a late player coming to the game. Okay, so I think that there was a real opportunity to create the new supernode, and it sort of has happened here. And so now, if someone else comes in, would they actually be able to make it attractive enough to do it? I do think that, there was capability that was sort of ripe to be taken because, the European hubs were really clogging down, okay? And I think that a lot of the success here has been able to be much, more efficient than some of those European hubs. But I haven't looked carefully at Turkey,
Not necessarily Turkey. Any other global sites you're looking at who could? Yeah.
I think there's some Asian sites, but again, Asia is not particularly well positioned to be a center node. I mean, one of the things, you don't have to be perfectly in the geometric center in order to work it, but it's it's hard to see, for example, people wanting to go from New York to Australia wanting to go to somewhere in Northern Asia because you're actually adding a lot of distance. So, but it's possible. I don't know of any that are sort of emerging at the same level as here.
Thank you.
Thank you very much. So much there to think about. But really the theme, I think, is looking at one of the world's great global cities in New York and Abu Dhabi, which is an aspiring one. And I think of that curve that you plotted that had Abu Dhabi down low on the curve, but following an inevitable trend upwards to the problems of New York in sustaining that connectivity that you need as a global city. And I think about other global cities that are probably high up on the curve with New York, maybe not quite as severe, but London, Tokyo.
Well, London's probably up there, right?
Yeah, and Tokyo's not in a great position, the Pearl River Delta. So here we are. Another one of your slides looked at the footprint from this part of the world, and it's a wonderful geographic location given the capabilities of modern aircraft and the range. So I guess that comment, or really a question to you, is there a way that we can sustain this move towards a global city that's connecting transcontinental links through this part of the world without getting into the difficulties of New York and other global cities?
Well, like I said, I think that you have a natural advantage in the weather, and you, for the moment, have a natural advantage on the land and location. The one thing that you should think about, which is the sort of lesson learned on almost all airport development, is you always develop airports where there's nothing around, right? Okay, so you go find a place where the land is cheap. Okay, And then what happens is people start to build around the airport because, so suddenly the airspace in the periphery starts to become attractive. Ultimately, that limits the expansion capability of the airport. So the one thing that you can do, and again, I don't know enough about the details here, is to make sure that the airports you're investing in the future have sufficient buffer to sort of grow in terms of a long-term plan, not just the next runway, but sort of as big as you could envision, and sort of buffer that in some way. Because, and we see this, I mean, the classic in the US is Washington Dulles Airport. When that started, there was nothing in the vicinity. It's now, one of the most quickly growing regions in the US, and there's going to be no capability to expand, Dulles from its current boundary. By the way, the other interesting airport there for different reasons is Mumbai. So Mumbai is an airport for which there's totally saturated, okay? Very low performance airport, terrible geometry, but it's ringed with in some what they call encroachment, people living on the periphery who for politically you can't move. So there's no ability to expand the Mumbai airport for similar things. So I think that's the one thing that you can probably think about. And right now it seems like, okay, nobody would ever want that, but you probably will sometime in the long-term future.
Good evening, Professor. Sorry, I missed your slides and presentations. I'm from Abu Dhabi International Airport.
Sure.
Some figures just that we can start this discussions. We are showing a growth of 6.8% on the traffic growth from now until 2030. Abu Dhabi International Airport handled 110,000 movement for 2010 with over 10,000 millions of passengers. Mm-hmm. The forecast indicates that we're going to hit 30 million passengers by 2030, with also the daily movement of traffic going to go to 700 movements per day. Looking at the growth of the traffic within the Abu Dhabi airspace and within the airport, Abu Dhabi Airport, currently we using the performance-based navigations, we're using RNAV1s, we being the first airport within the region implemented the RNAV1 procedure, and currently we're going for 3 mile separation and putting a safety case for applying 3 mile separations. My question is, looking to all these figures, we want a comparison within the United States, if any airport doing similar movement of 110,000 with 30 million passengers, what type of instrument or procedures that available, which, for the capacity enhancement. As we know, the growth of traffic demands the ATM needs. Mm-hmm. So if sort of comparison and what type of the instrument approach procedures to be developed at that stage.
Yeah.
Thank you.
I mean, it sounds like you guys are in good shape from a performance. If you're doing the RMP procedures now and you've got RNAV departures, you might, but again, the weather's here is good enough that you probably don't need local augmentation. You don't need GBAS systems. That's one thing you can do. There is a test of a GBAS system going on at Newark right now, so there are a few things that are going on. And I think the other question is just to look at your operational tempo, in terms of controller performance and things like that. But it sounds like, and I'm sorry you couldn't be here from the beginning, but I actually showed some of the improvements that you've got, or the increases you've had in the traffic, and pointed out, like I say, the weather advantages, the ability that you guys have to grow because you can add runway capacity that's very difficult in the U.S. I would also say that one of the advantages that you have is it's easier for you to change your procedures. It's actually been easier for you to do some of these more modern procedures than it is to do in the U.S. Because when we have existing procedures in the U.S., if we actually want to go to a performance-based nav procedure, We actually have to do an environmental impact statement and go through all kinds of work. Plus, we have difficulty with the labor unions. The controllers don't want to change the procedures and whatever. So in some sense, because you're building your system now, you actually can build a modern, better system than the kind of old system that we built in the US, where we're kind of correcting for that. And it's sort of hard to change, as you know. And once you get procedures installed, it's very hard to shift them there. So, but I'll be happy to talk offline. It's on a more specific level about analysis there.
I have 2 points. One of them is you mentioned correlation between the degree of economic development, GDP, and air transportation. What other factors which can be included to assess this measurement between the air transportation, economic development is one, but are there other factors which come into the picture when you assess air transportation, the degree of air transportation? Will it be expanding, or how much it will expand according to other than economic development processes? Yeah. The other question is China syndrome and India. How will that play into the equation when China is liberalizing its economy and it has its own vision and strategic position in the world as well, particularly in the Middle East and the Gulf as well. So how that will play when you check on the competition going on between China and India and the US in this region? Yeah. Thank you very much.
So most of the analysis that's done, you can look at air transportation correlation with a lot of stuff or drivers. The thing that correlates best, what, for example, Boeing and Airbus use to do their own internal predictions of what the traffic demand will be as just GDP. At the end of the day, sort of GDP is the best correlate, okay? And so we know there's a strong correlation. We just don't know what causes which, right? So this is why we have this hypothesis that in certain regions, like here, clearly here, one of the places where it's the easiest to see is an island nation. So Jamaica, we did a study in Jamaica. Okay, there would the huge tourism market in Jamaica wouldn't be there if you didn't have air transportation. Okay, so you can see a clear dependency. So regions which are geographically isolated, okay, for which it's hard to travel to, need to connect into the system. And given the tempo of today's economy, if you can't connect with air transportation, you're basically not there. So we think that there's secondary evidence that supports it, but like I said at the beginning, it's very hard to prove causality of what's there. But from a straight correlation basis, GDP is the best. Now in terms of what China and India are planning to do in the long haul, I've actually worked on the infrastructure in both China and India. India is got its handful just sort of trying to keep its own system going. So I think they're more of a market, and they're trying to get this economic enabling effect of connectivity. So they're going to want to have stronger connections. I think China, it's a more they've got other aspirations. So so China has a declared policy of trying to be a player in the aircraft manufacturing business. They're not there yet, but they're going to put a lot of money into it. I think it's interesting, as I pointed out, that their investment in rail infrastructure. So they've recognized that they would probably, if we just projected a U.S. activity level to where they want to be economically, you couldn't do it with air transportation. So that's why they're investing, I think, in the high-speed rail. But there's interesting politics in China. The airplane guys compete with the rail guys for funding. So, we'll see.
I heard a couple of questions about globalization and global flights and things like this. What is the role of the International Civil Aviation Authority in this? Thank you.
I didn't quite hear the beginning of the question.
I said I heard some question about globalization and traffic rights and all this. So I am asking, what is the role of the ICAO, the International Civil Aviation Organization, in this?
Okay. Now you're getting way above my pay grade. So ICAO works, there are the sort of standard, original ICAO agreements and whatever, so they're the framework under some of these things. Right now, all our agreements on sort of traffic rights are formed through bilateral agreements. One of the trends that we see are bigger opening of open skies agreements in many of these developing countries, like India has been very liberal in terms of their open skies agreements. China has not. Okay, so you have different sort of politicals, but those are not done through ICAO. Those are done on bilateral agreements between the different nations. I don't think ICAO has the authority to really enforce that. They've sort of defined the rights, but you have to, as I understand it, need to negotiate them. But you may know more. Yeah, follow on.
I'm sorry, I'm talking about not the bilateral agreement. I'm saying about the routes.
Oh,
the routes, the air traffic routes.
Oh, the air traffic routes that are flown through the country. When you say routes, I thought you meant the agreement to fly route. Well, the routes are approved by each air traffic service provider for the country. For that country, there are again agreements on how that's done and what the charging should be. And ICAO does have a significant. ICAO has a significant role in the setting the charging in the agreements in the international flight information regions between countries. But over sovereign domestic airspace, each country has the right to do its own thing, and then often there's negotiated. So in some smaller countries, you'll have someone else handle it for you, as I understand it.
I'm interested in the land use perspective and implications on airport expansions. And New York's Regional Plan Association recently put out a report with the Port Authority there about the need for a $million or billion-dollar expansion of the infrastructure in the New York region. And so in New York, you don't have the constraints, or there are constraints that don't exist here in the Emirates geographically. But in a setting where development exists and there's really a finite amount of land, how much of a self-fulfilling prophecy is creating more space at airports in bumping up against constraints? Does it follow the model that interstate highways do, where if you build the capacity, of course it's going to just fill up, it doesn't actually solve the problem of congestion?
Well, yeah, you'll get, if there's sufficient demand, it'll fill up, and then at some point you'll get to restriction. So that, now, if you believe that there's a correlation between economic development and air transportation activity, the bigger you can make your air transportation infrastructure, the bigger potential you have before you start limiting your economic potential. So you're absolutely right, you'll grow to that limit. And the question is, if you believe the hypothesis that air transportation stimulates economic development, then you would say we want as much air transportation capability as we can to grow the economy as we can. If you think that, well, people are just flying, but we're not getting a lot of benefit out of it, then you would restrict the capability. So the evidence is that even in places that are constrained, like New York, if there was an easy way to increase their capacity, they would do it, right? So it wouldn't be a bad thing. The question is, how much are you willing to invest, either in, finances or natural resources or whatever, to get that capability? And that's sort of where the debate is going to be in New York on the regional aircraft.
Just as a quick follow-up, so is there a point where better management is a more wise investment versus additional land acquisition or infrastructure creation? As in the highways, we can't build anymore.
Sure.
So now people have managed the resource rather than built.
I think that you want to do both. Well, you clearly want to manage as well as you can, right? So that's obviously a no-brainer, is you want to manage it. If you can't increase your infrastructure resource, then your only alternative is either to manage better, and there are two options on managing better, okay? One is you can improve the efficiency by which you operate the system. That's what we're trying to do in NextGen. The second is that you can manage by somehow prioritizing or restricting people's access to the system. But this gets to be this is when you go into slot restrictions and whatever, this becomes very tricky because there's a lot of politics. And okay, I have a limited number of slots at the key airports. Who do I give them to? Do I give them to the incumbents, or do I give them to new entrants to stimulate economic development? So it's a very tricky, and the evidence is it's not a very efficient system once you start allocating slots. So, okay, thanks. I guess that's
I hate to put an end to questions. I saw the hands, but